I'm Allison Singer with the Autism Science Foundation. We're here at the International Meeting for Autism Research with one of our pre-doctoral fellows, Christie, who's working with Dr. Monica Justice at the Baylor College of Medicine. Thanks so much for joining us, Christie.
Thanks for having me here, Allison. It's great to be at IMFAR again this year.
And you are working on a project called Genetic Modifiers of Rett Syndrome in the Mouse. Why don't you start by telling us a little bit about Rett syndrome, what it is, and how it's relevant to the broader autism community.
Okay, well, Rett syndrome has long been considered one of the autism spectrum disorders. It's really not completely unique at this point, but it was one of the first autism spectrum disorders that we knew the gene for. So Rett syndrome is caused by a mutation in a gene called MECP2, methyl CpG binding protein 2. And this is an X-linked gene, and so it turns out that with Rett syndrome, primarily girls are affected because since males have only one X chromosome, if they have a loss of function mutation in this MECP2 gene, they don't survive even to birth. I don't have a nicer way to say that, but so primarily this is a female neurological disorder, and it's just a really interesting situation because the girls go through this period of regression where they display autistic features and they have this really stereotypical hand-wringing phenotype. They have other problems, breathing issues, eating problems, and also very high incidence of seizures. So basically, it is one of the autism spectrum disorders, and it is one in which we know the gene that causes it, which allows us to do more genetic research and to find out, kind of pinpoint the pathways leading to this disorder. And I believe that'll be very interesting for the rest of the autism community, where maybe the specific genetic challenges aren't as obvious.
Now, one thing about Rett syndrome, as you said, is we know the gene. So we're able to make a mouse model of Rett syndrome.
Exactly.
Why is it important for us to have mouse models?
Well, mouse models allow us to do things that we simply could not do in humans. So, for instance, about 4 years ago, we learned something very interesting about Rett syndrome with the use of the mouse models. So Adrian Bird's lab over in England actually created a model in which they completely knocked out MECP2 in the mouse and then reintroduced it when the mice already began showing a phenotype. So like I said, in the humans, there's a period of regression. This occurs in the mice as well. They are born looking fairly normal and then have a situation in which they develop neurological problems, tremors, and the like. And also, I mean, they're such a wonderful model. You pick them up by their tail and they do that same hand-wringing motion that you see in the girls. So it's striking. So what Adrian Bird's lab did is, after these symptoms began occurring, they reintroduced the MECP2 protein into these mice, and the mice got better. So whereas people had been thinking that Rett syndrome is this progressive developmental disorder, it's irreversible, it turns out that's not actually the case. It's something that can be reversed, which is really something that provides a lot of hope for Rett families, but also to me for a lot of autism families where we might have situations of people thinking this is irreversible and maybe it's not.
So now, I mean, clearly our long-term goal is not to cure the mice. So how do we move from mouse models to treating real children?
People, okay. Well, that I think is where my research really comes in. So we have created secondary random mutations in mice with the initial MECP2 knockout. And basically, we let the mice tell us what other genes are important in the pathway. So by creating random mutations, we were able to look and see, are there mice that actually don't get the Rett syndrome phenotype as early with some secondary mutation? And we actually did find 5 lines of mice in which this was the case. they lived longer because it turns out the ret mice die younger than typical laboratory mice. So they survive longer and don't develop the same symptoms with the same level of severity. So this tells us that our random mutation is a modifier of the Rett syndrome mutation. And what you have funded me to work on is this one line that actually more than triples the lifespan of these mice. So I'm extremely excited about it. And we've actually been able to identify one of our candidate genes in this line. And it is a modifier, it's a modifier of Rett syndrome, but it's actually in the cholesterol pathway, which is something that people have never really considered seriously in Rett syndrome, but it's really common to consider the importance of cholesterol in other neurological disorders, Huntington's, Alzheimer's, and the like.
And in autism.
Exactly.
I mean, we do have some evidence that
Yes.
children with autism have very low levels
Yes,
of
so
cholesterol.
very low levels of cholesterol, and actually the kind of star of the autism world is specifically Smith-Lemli syndrome, where they have very low levels of cholesterol secondary to very high levels of a cholesterol precursor, which we're not exactly sure what's going on in Rett mice, but we're considering that as a possibility that there is some precursor that is perhaps toxic in the mice and in the people, obviously, but thinking that that buildup might be repaired with the mutation that we found. So obviously looking at the cholesterol pathway, you're asking how this can help humans. It's pretty easy to modify the cholesterol pathway, not certainly much easier than modifying, brain function and neuronal circuitry in adulthood. So I'm very hopeful that finding the mutations that I have, I could possibly, put a lead onto some drug targets and the like. So.
Well, we are so enthusiastic about funding this work. We're really looking forward to seeing the results of your study. But we are here at IMFAR, and you've been here a couple of days now. What's been the best part of being at IMFAR?
Really, it's been the ability to meet people. Certainly at ASF was kind enough to host a dinner for a few of the awardees and the Science Advisory Board, and the opportunity to meet many of them, share a meal, talk about science and not science was great. And also, some of the talks have been amazing. The opportunities to stop at posters, and actually this was the first talk that the first meeting that I've been to that I've stopped at a poster and actually given helpful advice to someone, which was, I felt like I had finally come into the world of science, so it's been very enjoyable.
Well, that's great. Well, we're thrilled that you're here, and enjoy the rest of the conference, and we can't wait to follow the progress of this work.
Absolutely.
Thanks so much.
Thank you.